Assalamu alaikum. Good morning, students. This is the next video for Unit 5, which is Alcohol, Grade 11 Chemistry, Unit 5, Alcohol. This video, I will be explaining about the concepts of Task 2 and Task 3. In the previous Task 1 video, we talked about the classification of alcohols into primary, secondary, and tertiary, and hopefully you have finished your Task 1. Let's start for the tasks 2 and 3, in which we are talking about the reactions of alcohols. So alcohols, like all organic compound, they have a one mandatory and one basic property with chemical property, which is called the combustion. All right. So combustion is the main property of alcohol, and another reaction is halogenation, which is also nucleophilic substitution. The third reaction is dehydration. Fourth is oxidation. Fifth is iodoform. There are five different chemical reactions for alcohols. In this video, we will be talking about only combustion and halogenation. Okay, let's start with alcohols. Alcohols, what is combustion? Combustion is the burning in the presence of oxygen. And alcohol is a very special flame, the brighter flame. Even different combination of alcohol will create a different colored flame. But most small chain alcohols like methanol and ethanol, their flames are so bright they can even burn with transparent flame, invisible fire. Mostly Formula One drivers, they are sometimes their accident happen and their fire erupt, and that fire is does not have any color, not even blue, not even yellow. It's really interesting. I've given you the link in the video. You can see there the problems arising when methanol or ethanol burns. So they're the distinctive property of combustion of alcohols. And for the complete combustions, as you all know, the products are carbon dioxide and water. For example, complete combustion of butanol. Butanol is CH3, CH2, CH2OH. Let's do it here. So when I go for the butanol, let's talk about the butanol. So yeah, so butanol have four carbon atoms. So formula would be CH3, CH2, CH2OH. Oh, there are three carbon atoms. Sorry, CH2OH, right? So I can write down in a simple form, it would be C4H9OH. You see, for this butanol is my favorite compound. So reacting with oxygen, because this is complete combustion, the products must be carbon dioxide and water. Right, we will now balance this, which is a different color. So how many carbon atoms? I have four carbon atoms here. I have only one carbon atoms on the other side, so I have to put four here. How many hydrogens I have? 9 plus 1, 10 hydrogens. Here I have only two hydrogens, so I need to multiply it by 5. How many oxygens on the other side? One oxygen here, two oxygen here. That will make it 3. How many oxygens on the other side? 4 times 2 is 8. 5 plus 1 is 5. 8 plus 5. So 8 from here, 5 from here. So total we need 13 oxygen here. Right? So for the 13 oxygen, one already there. Okay? We just need to put 12. So in order to put 12, it has to be 6. That's the complete combustion for butanol. Correct? Alright, let's do something different. So I would like to write down the complete combustion of 2-methyl. Let's talk about pentane 1-ol. Now, combustion doesn't look at the chain, all that stuff. All we need to know is the structure, and then from the structure we would be able to know the formula. Pentane means I have 5 carbon atom. Second carbon will have CH3 and the first will have OH, isn't it? These are the 2 hydrogens, 1 hydrogen, 2 hydrogen, 2 hydrogen, 3 hydrogens. So what I can do, I can write down now. It's better to write down from this side. So I can write down, better to write OH on the other side to give us idea how to, that will be OH here, hydrogen, hydrogen. So the formula would be CH3, CH bracket CH3 because it is a side chain. Then I have CH2, CH2, and then OH. Okay, when it react with oxygen, it must give you carbon dioxide and water. For balancing, same rule. How many carbon atom? 1, 2, 3, 4, 5. 5 carbon atom. 1, 2, 3, 4, 5. So I missed something. Okay, let's do it again. Let's do it again. So I will rewrite the, it will have CH3, then CH bracket CH3, and then CH2, CH2, CH2OH plus O2. The products are carbon dioxide and water. Now I will balance them better. We have altogether 6 carbon atoms, 5 for pentane and 1 for methyl, so it has to be 6. How many hydrogens? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14, I have a 7 here. How many hydrogens? How many oxygens? 6 times 2 is 12. 7 times 1 is 1, 7. 12 plus 7 is 19. 1 already here, so we just need to have 18, so 9 will be there. Okay, that's how you write down the balanced chemical equation for the combustion reaction. All right, I think I have done a mistake here. It has to be 613. It has to be 6. All right, okay, so that was combustion. Now you need to go to your classwork form and complete task 2 in the classwork form. Okay, once you finish, you can come back to the video and start the next reaction. About this reaction is halogenation, nucleophilic substitution, because alcohols have OH and OH are negative, so they can undergo nucleophilic substitution reaction. It is the breakdown of OH-CO bond because OH is removed. OH is replaced by halogen, mostly Cl. Okay. Chlorinating agents, what do we need them to react with? Chlorinating agents. And very famous chlorinating agents are phosphorus 5 chloride, which is formula is PCl5. Another one is thionyl chloride, which is SOCl2. In all those reactions, along with the organic product, another product is produced, which is HCl. And how would we know? This has a very, very distinctive observation, which is the steamy, misty, acidic fumes with a very pungent smell. You can't smell it, just goes straight to your nose, to your head. So it is very, very pungent smell. Okay. So how do we have this reaction? So ROH means alcohol reacting with PCl5, and it's gonna go you RCl, HCl, POCl3. Let me explain you in the note. Okay, how do I work it out for that? So let's talk about this one. So I have, let's say, CH3 CH2OH. I'm going to react it with PCl5. Okay, this PCl5 is a chlorinating agent and it will undergo halogenation reaction. What is halogenation reaction? Halogenation reaction is the replacement of OH with Cl. So what will happen now? So you see CH3, CH2, and then the OH is replaced by Cl. Wherever OH is, doesn't need, don't have to worry about anything else. Just wherever OH is, and how many OH we don't care. All OH will be replaced by Cl. Now, when you look at the number of atoms, and I told you that there are one product which is HCl, which will give you a distinctive pungent smell or the steamy, misty, acidic fumes. Alright, now what about the other? Remaining atoms will combine together to give you the last product. How now? We have one O and one H, we had one P, and we had 5 Cl. I'm writing down all 5 Cl here. So in this one, OH is replaced by Cl. Cl is used out. HCl is produced. So H and Cl is also gone. So now what left here? 1P, 1O and 3Cl. So the third product we have called POCl3. That's how we write down the equation. Always remaining. These two are mandatory and the remaining atoms will combine to give you the other product. What is the name of this compound? Because we have chlorine in it and two carbon atoms, so the name should be chloroethane. Because there are only two carbon atoms, we don't need to write down one chloroethane. It applies when you are dealing with more than two carbon atoms. Alright? The another chlorinating agent, I will explain you for the another chlorinating agent is, let's talk about this one. Another chlorinating agent we can deal with. Let's talk about this one. CH3, CHOH, and CH3. This compound is called the 2-propanol. Okay, I'm going to react with SOCl2. Now, SOCl2 is another chlorinating agent. The chlorinating agent means the OH is replaced by chlorine. So I would say CH3 is not changed. CH is not changed. The OH is replaced with Cl. And CH3 not changed. That's, if you understand that logic of organic chemistry, that only the functional groups are changed, you are expert. You can do any question in organic chemistry. So when you learn the organic reactions, make sure you just need to change the functional group. What have I done here? You see the OH is replaced with Cl. Rest of the whole molecule has no effect, no change, right? Also, I told you that HCl is also produced always. Okay, let's talk about the other product. Okay, so what happened now? So we have O and H here. We have one S, one O, one Cl, two Cl here. So we have replaced OH with Cl, so one Cl gone. For the HCl, we got one H and one Cl gone. So what left on the other side is one sulfur and two oxygen. So sulfur dioxide is produced. Sometimes these product will tell you what was your reagent. Okay, so POCl3 is only produced when you're dealing with PCl5, and SO2 only produced when you're dealing with SOCl2. Correct? This is the halogenation reaction. Okay, these are the two general forms. So we have given some examples here, and also an alcohol with chlorinating agent 2-chlorobutane. So chlorinating agent will replace alcohol with chlorine. So the alcohol should be 2-butanol because there must be OH on second carbon atom. Okay, because chlorinating always replace OH with Cl. So there is a Cl on second carbon, chlorine on second carbon, so it has to be butane 2-ol. Sulfur dioxide. Sulfur dioxide only produce when you deal with SOCl2. So your alcohol is butanol, 2-chlorobutane, and the chlorinating agent is SOCl2. Sorry. The last one, 2-methylbutane 1,2-diol. Now, that's very tricky. So I will open 2-methylbutane 1,2-diol. So butane means we have this, 2-methyl means we have this, 1,2-diol, right? Rest of them are. Now there are two OH groups. There are two OH groups. So what happened now? The both OH group will be replaced with Cl. So I won't change anything. So 1, 2, 3, 4, CH3 here. Rest of the molecule is same. So what happened now? Wherever OH are, it will be replaced with Cl. Cl here and Cl here. And the remaining products all we will write like same as HCl and POCl3. We don't have to worry about balancing. If you really care about balancing, so one PCl5 is needed for one OH. So we got two here, we got two here, and we got two here. So in organic chemistry, we don't really care about. Sometimes we care about, but not always. So if you don't know how to balance, no problem. But you need to know the concept is no matter how many carbon OH groups, all will be replaced. Okay. So note if there are multiple OH group present, then all of them will be replaced with Cl. Okay. For each OH group, one POCl, PCl5 SOCl2 is required. All right. If you have any problem, we will be online on our contact time on any other time. Just email me or Mr. Faisal. We will be there to help you out. Okay, don't worry about it. Now you need to go for task 2 and task 3. Okay, have a great day.